James Tierney, TierneyEducation.com with another video, this time looking at implicit differentiation. Make sure you subscribe to the page so you'll know when I post videos like this that are requested from my students. And if you would like a free 30-minute consultation, head on over to TierneyEducation.com where you can sign up for 30 minutes or more when it comes to private economics and math tutoring or academic coaching. So this is the question that I got from my student. He gave me this equation and said what he's trying to figure out is dy dx. So how can we see how this, whatever his function ends up being, right? This isn't necessarily a function, but whatever this ends up being, how does it change with respect to x? Or the way that his class does it a lot is y prime. So we're going to do implicit differentiation here. This is not going to go over exactly how to do implicit differentiation. You can look up other videos on that. This is simply just a practice problem with implicit differentiation. The first step I told him he should do is this first function here, ln of xy. Let's take this ln of x plus ln of y. We're just going to simplify this down a little bit. Let's write everything else out. Plus y to the 9 equals x to the 6 plus 2. Really, this question that his math professor is asking him to do is really just making sure you know how to do the steps and then can do some algebra along with it. So now the implicit differentiation, we're going to take each one with respect to x. This first one has x in it, so we know the first derivative is just 1 over x. The second one we're taking with respect to y is 1 over y, but we have to put that y prime next to it because we have to, it's like the chain rule, right? We're taking the derivative of it with respect to x and then the derivative of it with respect to y, etc., etc., etc. Same thing with this next one. This is going to be 9y to the 8th, but then you have to do y prime times it again. It's just like the chain rule. On the right-hand side, we don't have to worry about that implicit differentiation with y because there's no y's, so we just have my 6x to the 5th. And then the derivative, how is 2 changing with respect to x is just going to equal 0, so we're not going to put anything there. Now, in order to solve out for dy dx or y prime, I have to isolate my y primes. The way I'm going to do that is I'm going to take this 1 over x, throw it to the other side here. So what we're going to get is 1 over y times y prime plus 9y raised to the 8th power times y prime equals 6x to the 5th minus 1 over x. I'm going to make this a little smaller just so that we can fit everything on one page. I'm now going to factor out the y prime. I'm left with 1 over y plus 9y to the 8th equals 6x to the 5th minus 1 over x. And I'm going to divide both sides by 1 over y plus 9y raised to the 8th. So this side is 1 over y plus 9y raised to the 8th. Again, I'm going to make this just a little smaller so I can get everything here. And what we have is y prime equal to, right, this stuff's going to cancel. So we're going to have in the numerator 6x raised to the 5th minus 1 over x. And then we have 1 over y plus 9y raised to the 8th. And maybe we could stop there, but I like to, if we have a numerator and denominator both with a fraction, let's go ahead and, rationalize or whatever you want to call it, get rid of those fractions. So I'm going to multiply the top and the bottom by x times y. And this is a legal math move, right? I'm just multiplying this by 1, so I can do that. And if I distribute this through, you can see I'm going to get 6y x to the 6th minus y, because if I distribute this x times y to here, the x's will cancel. I'm left with just a y. And then on the denominator, I'm going to be, again, if I distribute this through here, the y's will cancel. I'll be left with just an x plus 9. And then we have an x, and now we have a y to the 9th. And you can even make this look a little better, where it might be 6 to the x to the 6th times y minus y, divided by 9x y to the 9 plus x. So you could do any of this type of stuff with the algebra if you wanted. But at the end of the day, what we're trying to get through with this video is if you are given this type of equation or something like this, how do you solve for that dy dx or y prime, depending on how your class denotes it. And again, this is implicit differentiation. We're just going through each thing one at a time. If it's just an x, we're just doing our regular derivative. We're taking how does this change with x? But if there's a y, we're saying how does it change with x? Well, first we have to see how it changes with y, and then how it changes with x. Again, implicit differentiation is really just the product rule. How does it change with y? How does it change with x? How does it change with y? How does it change with x? We do that for every single part here. We do it, then it's just algebra to get us down to a simplified version like this. I hope this explanation helped you out. Please follow, like, subscribe, reach out to me if you have any help. Let me know in the comments if there's another question you want me to do, and hopefully we'll see you sometime.